Hello everyone and welcome. Today, we are going to demystify a very common reagent you will constantly encounter in your organic chemistry course, NaOEt. You've probably seen it written over a reaction arrow and wondered what exactly it does. Is it a base? Is it a nucleophile? The answer is both, and by the end of this video, you'll understand when and why it chooses each role. So, what is NaOEt? The name stands for sodium ethoxide. It's an ionic compound, made of a positive sodium ion, Na+, and a negative ethoxide ion, Eto. The Et part just means an ethyl group, which is a 2-carbon chain. Essentially, it's the salt you get when you react ethanol with a strong base like sodium metal. In the world of organic reactions, sodium ethoxide is known for 2 key behaviors. First, it is a strong base. As a strong base, its main job is to abstract, or pull off, a proton from another molecule. This is its most common function in elimination reactions, particularly the E2 reaction. Imagine you have an alkyl halide, like 2-bromopropane. The ethoxide ion can come in, grab a hydrogen from a carbon adjacent to the carbon with the bromine, and in a single concerted step, a double bond forms to create an alkene, and the bromine leaves. This is a classic way to synthesize alkenes. Second, sodium ethoxide is also a good nucleophile. A nucleophile is a species that donates an electron pair to an electron-deficient center. The oxygen atom in the ethoxide ion has lone pairs and a negative charge, making it eager to attack a partially positive carbon. This is what happens in substitution reactions, specifically the SN2 reaction. For example, if you react NaOEt with a primary alkyl halide like bromoethane, the ethoxide ion will attack the carbon bonded to the bromine, kicking the bromine out and forming a new carbon-oxygen bond. This specific reaction is a great way to make ethers and is known as the Williamson ether synthesis. So, how do we decide if it will act as a base or a nucleophile? The key factor is steric hindrance, or how crowded the reaction site is. If you have a primary alkyl halide with very little crowding, the nucleophilic attack, SN2, is favored, and you'll form an ether. If you have a bulky, tertiary alkyl halide, the ethoxide ion can't easily reach the carbon to attack it. It's too crowded. So, it will act as a base instead, plucking off a proton from the outside to cause an elimination, E2, reaction, forming an alkene. For secondary alkyl halides, it's a competition, and you often get a mixture of both products. And that's a quick introduction to the dual personality of sodium ethoxide. Thank you so much for watching. I hope this video helped clarify its role in organic chemistry. If you found this explanation useful, please consider liking the video, leaving a comment with any questions, or subscribing to the channel. Your support is greatly appreciated and helps me continue to create more chemistry content for you. See you in the next one.